Friction 1, numerical number 14. A block A of mass 4 kg is placed on another block B of mass 5 kg, and the block B rests on a horizontal smooth table. For sliding the block A on the block B, a horizontal force of 12 Newton is required to be applied on it. How much maximum horizontal force can be applied on B so that both A and B move together? Also, find out the acceleration produced by this force. Numerical number 14, friction 1. In the diagram, a block of mass Ma is placed over another block of mass Mb, and given quantities are Ma equal 4 kg, Mb equal 5 kg. Mass of the block A is 4 kg and mass of the block B is 5 kg. An external force Fx is acted on the upper block of mass Ma, and weight of the block A, that is Mag, acts downwards, and reaction force on the block A is R1. Similarly, weight of the lower block of mass Mb is Mb into G, which acts vertically downwards. Reaction force on the block B applied by the floor is R2. R2 is the normal reaction on the block B. We can denote the limiting friction. Here Fl is the limiting friction acting on the surface in contact between the upper block A and the lower block B. The value of the applied external force Fex is 12 Newton. Fex is equal to 12 Newton, which is the force applied on the upper block A placed on the lower block B. Fex is equal to 12 Newton. If the applied external force Fex is the horizontal force, if Fex is the horizontal force applied on the upper block of mass Ma placed on the lower block of mass Mb, if Fex is the horizontal force applied on the upper block A for sliding it over the surface of the lower block of mass Mb or the lower block B, the upper block of mass A of mass Ma will be at the verge of moving if the limiting friction Fl is equal to applied external force Fex. That means Fl is equal to Fex, and here limiting friction under bracket Fl is equal to mu into R1, where Mag is the weight which is acting downwards, Fl is the limiting friction which acts in the opposite direction, and normal reaction is R1. So in place of Fl we can write mu R1 is equal to Fex, or mu Ma into G. In place of normal reaction R1 we can write Ma into G is equal Fex, or mu is equal to Fex divided by Ma into G, or mu is equal to, putting the values of Fex and Ma, we get mu as equal 12 divided by 4 into 9.8. Therefore the value of coefficient of static friction mu will be what? Mu will be equal to 12 divided by 4 into 9.8. That means mu is equal to 0.306, which is the value of static friction between the two blocks. Mu is equal to 0.306, which is the coefficient of friction or coefficient of static friction between the upper block A and the lower block B. Mu is equal to 0.306, which is the coefficient of friction of the surface in contact between the two blocks. Let Fex prime be the force applied to the block B, which is placed on a smooth horizontal surface. Let Fex prime be the force applied to the lower block B, which is placed on a smooth horizontal surface. Fex prime be the force applied to the lower block B, and here the block B is placed on a smooth horizontal surface. So Fex prime be the force applied to the lower block B, which is placed on a smooth horizontal surface. Hence, to move the block A and B together, the maximum force, the maximum value of force under bracket Fex prime will be equal to the sum, of frictional force, applied on the upper block A by the lower block B, and this force will be FAB, and the frictional force under bracket FBA applied on the lower block B by the upper block A. The frictional force FBA applied on the lower block B by the upper block A. The lower block B by the upper block A. Therefore, Fex prime will be equal to FAB plus FBA. Fex prime is equal to FAB plus FBA. In this case, limiting friction FL is equal to FAB plus FBA, and this limiting and the applied external force Fex prime will be less than equal that limiting friction FL, Fex prime will be less than equal FL, or Fex prime is equal to mu R1 plus mu R2, or Fex prime is equal to mu under bracket R1 plus R2, that is Fex prime is equal to mu under bracket MAG plus MBG, or Fex prime is equal to mu MA plus MB into G, or Fex prime is equal to 0.306 into 4 plus 5 into 9.8. Putting the values of mu, MA, MB and G, we get this. Therefore, Fex prime is equal to 26.99 Newton. Fex prime is equal to 26.99 Newton, that is the maximum value of applied external force. And this is the answer, and Fex prime is equal to 26.99 Newton, which is the maximum horizontal force applied on the lower block B, so that the two blocks A and B move together, with the common acceleration, A. Fex prime be the external force applied on the lower block, and we can denote the acceleration of the upper block A1 as A. Similarly, the lower block B will be moving with the same acceleration A2 equal to A, and the friction acting between the lower block B and the smooth horizontal surface is FL prime, which will be 0. As the horizontal surface is smooth, there will be no frictional force acting between the lower block and the smooth horizontal surface, and two blocks will be moving towards right with the common acceleration A, which is Fex prime divided by MA plus MB. Putting the values of Fex prime, that is 26.99 divided by 4 plus 5, and we get the value of common acceleration of the two blocks under the action of applied external force Fex prime. We get A as equal 2.998, that means the common acceleration A will be equal to 3 meter per second square. A is equal to 3 meter per second square, which is the common acceleration of the two blocks A and B under the action of the applied external force Fex prime to the lower block.